Okay. So this is it, right?
Yes.
Right. Well, I mean, you've kind of identified the real hard point of this whole proportional method. Um, I I typically think of this as part to whole rather than is and of. So when you're looking at a question, you're trying to figure out which one is the part and which one is the whole. So, or in a situation where you have only one of them provided, like three and four, a good example of like one of these is a part is given to you, the other one is that the whole is given to you. And sometimes I like to think of it as kind of a drawing. Maybe that'll help some of you think about it. Okay, so like I said, I like to think of it as part to whole equals the percent over 100 rather than the is and the of, because I think the is and the of is kind of simplistic. It's meant more for the sentences that are like 35 is what percent of 26 or something like that. But when you're dealing with a full sentence, that's a description of a situation, and then you're just kind of trying to figure out, well, does this go on the top or the bottom, right? That's kind of the heart of the issue. So the picture that I'm thinking of in my head is this, kind of like a little egg. This is the part, and this big circle is the whole, right? Because this group here is a part of the larger whole. So in question three, they're talking about Americans and they're talking about left-handed people, right?
Hmm.
So which group is the whole and which group is the part? Are Americans part of the left-handed people or are the left-handed people part of the Americans?
Left-handed is a part of the Americans.
Right. So that's how I would envision this picture. I got my left-handed people here, and then that's part of the larger group of American people, right? And so if they give me the number of Americans, then they're giving me the whole. If they give me the number of left-handed people, they're giving me the part. So that's how I make that decision. There's really a lot of thinking that has to go into that. It's not as simple as, well, you see this, you could put it up here, you see that, you put it down there. And that's the problem with the whole is of strategy, is it was intended to make it very easy, but it's really not that easy. You got to think about it. You got to say, okay, well, let me think about this situation. Okay, so let me tell you a story. Give you an example. If I have, let's say I'm having a party and I got a bunch of people coming, and you know, some of those people are driving. So if I'm talking about the drivers and I'm talking about the people who came to the party, which one is the part and which one is the whole? And again, this little visualization here, there's the big circle, that's everybody, and there's this smaller group, that's my part. So which group is the part and which group is the whole? I've got drivers, and then I've got the people who came to the party.
The drivers are part.
The drivers are a part of the people who came to the party, right? So I would put the drivers in the small circle, and I would put the people who came to the party in the large circle. And depending on, so maybe my question is 36 people came to the party and 12% of those people were driving. How many people were driving? So what I've given you then is the number of people who came to the party. That's the whole that goes on the bottom. So that's the kind of thinking and reasoning you have to go through to figure out who's on top and who's on the bottom. Okay, so this is an example of a type of problem you would get. And presumably at this point, you've seen the videos about the proportional approach. I'm going to give you a minute to kind of think about how you would set that up, and then I'll set it up, and then we'll look at the answer. Get my calculator. Okay, so that's always my starting place for a proportion. What can we, if we're going to use proportions to solve this percentage problem, what do you know goes where?
So it'll be the percent on top, the 1.35 over 100.
Okay, good. So that's half the problem set up. And that's an easy one because the percent sign is the giveaway that that number goes there, right? We're not changing this into the decimal form of it. That's a different issue and a different process. For this proportional approach, we just write 1.35 over 100. And that's because 1.35 over 100 is literally equal to 1.35%. That's just another way of thinking about it. Okay, now we get to the hard part. That 2,400, does it go on the top or does it go on the bottom?
It's a whole, right? So it'll be 24. So the whole will go on the bottom.
Good, part to whole, 2,400 on the bottom. We're wondering the part of our money that's going to have to go to Social Security withholding. So that's exactly right. Once I get the proportion set up, the nice thing is it's just multiply and divide to finish the problem. It's just pretty straightforward. So I ended up with 32.4. This is money. So I'm not going to do any rounding here. This is $32.40. Okay, any questions about that problem? So the whole concept there is just to build off of the success you had in proportions to be able to answer percentage problems. Not the only way to solve percentage problems, but just making a connection, right? So it's kind of a through line so far. We started with ratios, we connected that to proportions, now we're connecting that to percentages. So that's one of the ways that we could try to help make sense of things, is to try to make sure stuff's connected and not doesn't feel disconnected.